At what point or points in the interval 0 included, 2 pi not included, is the tangent line for f of x equals sine 2x parallel to the line y equals x minus 5? Parallel lines have the same slope. The slope of the line given, y equals x minus 5, y equals 1x minus 5, y equals mx plus b, whatever's with the x is the slope, right there. That line has a slope of 1. We want our slope of tangent line to be a 1 so that we have our tangent line parallel to that line. The slope of the tangent line is the derivative. We have a function, sine of 2x. We can find its derivative to give us the slope of the tangent line. The derivative will be start with the sine, it's cosine, leave the inside alone, and then multiply by the derivative of the inside to complete the chain rule. That 2 does not multiply the 2x in cosine. It moves to the front. 2 cosine 2x. There's our slope of our tangent line at any x coordinate. We need this to be parallel to the other line and have a matching slope. So we're going to set this one also equal to 1. So I'm going to start by dividing both sides by 2. That will give us the cosine of 2x equals to 1/2. So we have to think of all places where cosine is equal to 1/2. However, we're working right now on the phase of 2x because that's what's inside the cosine. It's a 2x. We want our final answer, x, to be in the interval of including 0, not including 2 pi. That's because 2 pi and 0 are the same location on the unit circle, so you always include the one and not the other. That's the interval for x. We have a phase here of 2x, and so I need to write down the interval for 2x. 2x is twice as big as x. You're going to double each of these. 2 times 0 is 0. 2 times 2 pi is 4 pi. There's the interval. We're going to try to think of where the cosine is equal to 1/2, because 2x is going to equal each of these. So where is the cosine equal to 1/2? The first place that occurs at is pi over 3. The next place that occurs at is in the fourth quadrant, and it will be 5 pi over 3. There's our two locations between 0 and 2 pi, where the cosine equals to 1/2. However, we have a 2x, and so we need to think of all the places between 0 and 4 pi. We need to go a little further. Now, those are the only two that are between 0 and 2 pi. Between 2 pi and 4 pi, there will be the same equivalent locations to each of these, and those are found by just adding 2 pi to each of them. So pi over 3 plus 2 pi, and 5 pi over 3 plus 2 pi. Now what I'm going to do here is rewrite the first two just as is. But the next two I'm going to be adding pi over 3 plus 2 pi. Let's get a common denominator. 2 pi can be written as 6 pi over 3. And I have 5 pi over 3 plus 6 pi over 3. And so I have pi over 3, 5 pi over 3, 1 pi plus 6 pi, 7 pi over 3, and 5 pi plus 6 pi, 11 pi over 3. There are all the locations where the cosine is 1/2 between 0 and 4 pi. This is 2x equals to this. So we're now going to solve for x. And solving for x, we divide both sides by 2. So I'm going to divide each of these by 2. That's going to put a 2 in their denominators with the 3 that's already there. So if I divide by 2, I end up with pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Notice that each of these are once again back to between 0 and 2 pi. So 2x, we had to go 0 to 4 pi, but then once we divide it by 2, the results end up between 0 and 2 pi. So there's our 4 places between 0 and 2 pi where the cosine of 2x is equal to 1/2. Now we want the points not just the x-coordinates. So what we need to do with each of these is go and find the corresponding y-coordinates. I'm going to start with x equals pi over 6. The y-coordinate will be found by plugging that in to the original function f. Make sure to plug it into f, not f prime. So y equals f of pi over 6, which is going to be sine of 2 pi over 6, which can reduce to sine of pi over 3. And the sine of pi over 3 is root 3 over 2. So I have x-coordinate of pi over 6 and a y-coordinate of root 3 over 2. The next one is x equals to 5 pi over 6. My y-coordinate will be f evaluated at 5 pi over 6, which will be the sine of 2 times 5 pi over 6, which is the sine of 10 pi over 6, which can reduce to 5 pi over 3. And the sine of 5 pi over 3, which is in the fourth quadrant, is negative root 3 over 2. So I have an x-coordinate of 5 pi over 6, and I have a y-coordinate of negative root 3 over 2. The next one is x equals to 7 pi over 6. My y-coordinate will be f of 7 pi over 6, which will be the sine of 2 times 7 pi over 6, which will equal the sine of 14 pi over 6, which can reduce to sine of 7 pi over 3. Now 7 pi over 3 is bigger than 2 pi, because 3 divides into 7 twice plus a remainder. So we need to get the equivalent of this back into the 0 to 2 pi range to make use of the unit circle. So we're going to subtract 2 pi from it. So I'm going to take 7 pi over 3 and subtract 2 pi, but I'll write that as 6 pi over 3. And that'll turn it into its equivalent between 0 and 2 pi. Well, 7 pi minus 6 pi is pi over 3, so we end up with sine of pi over 3, which is root 3 over 2. So I have the point 7 pi over 6 root 3 over 2. And now last of all we have x equals 11 pi over 6. My y-coordinate will be f of 11 pi over 6, which will be the sine of 2 times 11 pi all over 6, which is the sine of 22 pi over 6, which can reduce by a 2 to an 11 pi over 3. This is once again beyond 2 pi. So we will subtract 2 pi from it to bring it back to a unit circle range. I will call it 6 pi over 3, 2 pi equivalent. And 11 pi minus 6 pi is 5 pi over 3. And the sine of 5 pi over 3 is negative root 3 over 2, leaving us with the point 11 pi over 6, comma, negative root 3 over 2. And there's our 4 points in the interval from 0 to 2 pi, where the tangent line for the original function f of x is parallel to the line y equals x minus 5.